Hello students and welcome back to the chapter, and in this module we shall be studying restriction fragments and restriction endonucleases, which you have previously studied as molecular scissors. Now let us begin with the module. Here I have the term restriction fragments. Now what are restriction fragments? Take a look at this image. I have a DNA molecule and I have a restriction enzyme. When I cut this DNA molecule with the restriction enzyme, I get two fragments. And these fragments that result due to the action of the restriction enzyme are nothing but restriction fragments. So fragments resulting from the cutting of DNA by restriction enzyme are termed as restriction fragments. Now let us move ahead and take a look at the history of restriction enzyme. Here I have Werner Arbor and Stuart Lean. These two are credited with the discovery of restriction enzymes. Now let us take a look at how they did it. They took the bacterium E. coli, and from E. coli they isolated two enzymes in the year 1963, and they observed that one of these enzymes restricted the growth of bacteriophages, and hence they named these enzyme as restriction endonuclease. So that is how our restriction enzymes or restriction endonucleases were discovered. Now let us move ahead and take a look at the types of nucleases. Here we have the first one, which is exonucleases, and the second one, which are endonucleases. We shall study them one by one. So the first one we have exonuclease. Now what do exonucleases do? Here's the DNA molecule and here's an exonuclease enzyme. The exonuclease enzyme will be cutting the DNA molecule or removing the nucleotides from the ends of the DNA, that is the terminus of the DNA. So exonucleases remove nucleotides from the ends of the DNA. That is the function of the exonucleases. Now let us move ahead and study endonucleases. What do endonucleases do? Endonucleases will be removing nucleotides, or they will be cutting the DNA from in between the sequence or within the DNA. So here can you see that they remove nucleotides from within the DNA? So endonucleases make cuts at specific positions within the DNA. So that is the function of endonucleases. Now let us move ahead and take a look at the types of restriction endonucleases. We have three types of restriction endonucleases: type 1, type 2 and type 3. Out of these three, type 2 restriction endonucleases are utilized for rDNA technology or recombinant DNA technology. So type 2 restriction endonucleases are used in recombinant DNA technology. Remember that very well, students. And about 350 different type 2 endonucleases are known with 100 different recognition sequences. So there are a lot of restriction endonucleases available for research. Let us move ahead and take a look at the nomenclature or the naming of these restriction endonucleases. Now let us first understand how they are named. Restriction endonucleases are named with particular reference to the bacteria from which they are isolated. Can you recall that Stuart Lin and Werner Arbor isolated the enzymes from E. coli? So it was a bacterium from which they isolated it. So are the other enzymes. Now let us take an example of the first enzyme, which is known as EcoR1, where E stands for Escherichia, CO, that is CO, stands for coli, R stands for the strain RY13, and the Roman numeral 1 stands for the order of discovery. So EcoR1 is the restriction endonuclease isolated from Escherichia coli of strain RY13, and it is the first endonuclease isolated from the bacterium. So that is how they are named. Now let us take an example of another enzyme, which is known as HIN3. Here H stands for Haemophilus, IN stands for influenzae, D stands for the RD strain, and the Roman numeral 3 stands for the order of discovery. So HIN3 is the enzyme that has been isolated from Haemophilus influenzae of RD strain, and it is the third enzyme that has been isolated from the said organism. So that is how our restriction endonucleases are named. Remember that very well, students. Now, in this module, we studied restriction fragments and we studied restriction endonucleases. And in the next module, we shall be studying recognition sequences, cleavage pattern, and agarose gel electrophoresis. So till then, study well, take care, and bye-bye.